missed that. So we're talking about our unit circle. And hi, who's out there? Dylan's out there. And who else? Hamish, how are you, Hamish? Hope you're doing well. We miss you. Sorry, I forgot you, Hamish. So we've got our unit circle that we're filling out. That's got a radius of 1 there. So if we look at our triangle, this is 30 degrees and this is 1. And I would like us to find this height. I'm going to call that y. Right? And I would also like us to find this length, which we'll call x. And I'm calling those x and y for a certain reason, and that is because if you look at the triangle, this is on my x-axis. And this is the height, the y. So, you know, if you didn't call it that, that's okay, but I like to matchy-matchy. So, if we've got y, does everyone agree that this is opposite over hypotenuse? So that means I've got sine 30 equals y over 1, frowning at me, opposite hypotenuse. Happy days? Do I need to write that? And therefore, I mean, I love it. I love the 1 because y divided by 1 is just y. So therefore, y is sine 30. And on your calculator, what's sine 30? Check it. So I'm in degrees. So you can put your calculator back to degrees. And we should get sine 30 is a half. Now, what about finding my x? What's that going to be? That is now adjacent over hypotenuse, which is cos. So I've got cos 60 equals x over 1. So, oh yeah, why is it 60? 30. Thank you. I like to say, I'm just seeing that you're paying attention, but no, that was a mistake. Cos 30, and what do we get? No. So, wait before you call out what it is. Oops, it's not what I wanted. If we have a look, our sine, so our height, so we're saying that's a half, and do you reckon that's actually pretty good? Because that height is there 1, that's a half. It looks like it's halfway, doesn't it? Do you agree? Does this bit here, this is your x, does that look, that distance there, does that look like it's a half? No way, Jose. That looks like it's a lot bigger. It's closer to 1. If you were to estimate, what would you say? Like nearly up 0.9 maybe? So on your calculators, those who have scientific, you would get a decimal, but those who have graphic, they will tell you it's root 3 on 2, which is 0.86 something, pretty close to 0.9, yeah? Huh? We happy? So when I come now to my unit circle, any point here, right, that point, we know, if I was to just go, here's your x-axis and here's your y-axis and this is 3 and this is 4, what would this coordinate be? 3, 4, because you go x, then y. So that's the coordinate 3, 4. Agreed? Well, we're going to do the same thing here. Every coordinate, it's got an x component and a y component. But remember, instead of this being your x-axis, this is your... So close. That's your cosine. And remember your sine, doing your height, that's your y-axis there. So every single coordinate on this unit circle, right, every coordinate, your x is cos theta and your y value is actually sine theta. So this thing here, this coordinate, that is technically, I'm going to write it big. I should have left it out. That is actually cos 30 sine 30. You're not writing that because what did we say cos 30 is? Root 3 on 2. And what was sine 30? A half. It's going to come out nicely, don't worry. We want to do the same for this one. And I hope some of you are going, oh my God, look how many triangles we're going to have to do on this circle. We're going to be here all day. Are we? Oh, because look at this one right now. I reckon you should be able to fill this out just from having done this one, because hasn't it got the same height? Would you agree? So it's got the same y coordinate, which is a half. Do you reckon it's got the same x? Yes, because it's symmetry, right? So this point here is the same as this, except it is negative. So that's going to be negative root 3 on 2. Is there any other? Are there any other points that you can get just from having this triangle? The ones below, right? Look at this, right down below. You should be able to tell me what this coordinate is. How far across have you gone? Root 3 on 2. It's the same that you've gone across here. So I'll write that there. That there is root 3 on 2. So I've gone across root 3 on 2. Is it positive or negative? Positive. And look at that. It's so I've gone down the same distance there, negative a half. Sorry, is this too small? I'll write that bigger. Did someone just say they're so confused? Is that okay? And so now this one here, we've gone across that root 3 on 2, but again, it's negative, so negative root 3 on 2. And how far have we gone down? Negative a half. I hadn't planned on doing this, but you know, just goes, you're in a circle, it just goes with the flow. That was 30 degrees up there. So there, that's also 30 degrees. Remember, this is 360. I've come back by 30 degrees. So does that make sense that it's 330 there? And same from here. That's 30 degrees. So if you hadn't filled out your circle, 180 plus 30, 210. Gotta love it. I love it. I love it. Now mine's looking messy. I'm hoping yours looks nice. So Tom was going ahead and he's wanting to fill out more. And he's going, well, what about this point here? What's that? Good old normal axes. Tell me. It's 0, 1. And so remember, what this is actually telling you is that you now know cos of 90 is 0. And sine of 90 is 1. Because that's what each of these coordinates is saying, right? That's cos of 30, sine of 30. This is cos of 330, and this is sine of 330. If you don't believe me, pop that on your calculator and check. Oh, look, I've got a non-believer. Excellent. Put it on hell for leather now. This is going to be cos of 60, and this is going to be sine of 60. And you see something that's pretty groovy. What is it? I'm ignoring you. What's pretty groovy here? Yes? It's switched, and that becomes a half, and that becomes root 3 on 2. And does anybody know why? I'm going back to my triangle. 30 used up 90. What's that angle there? 60. It's all from the one triangle. Oh, I just love it. You don't care, but I love it. It's in your textbook, but we'll show you that later. And don't worry if you haven't put your radians bit in. Tom was talking before. We will add the radians in. We're just going to show you how it all connects. We looked at this in class last time, but now you're actually making it. So this, what colour shall we go? We'll go pink. This sine graph here, and I think you should label this. So this is on your second sheet that you should have, your sine graph. Please label that. Oh, look at that. Sine. Where that has come from is 0, 0 is this one here. Ladies, so remember all of your y coordinates, all the xy, all your y coordinates are your sine values. Do you agree? Because it was xy cos sine. So here at 0 degrees, it was 0. Here, this was 30 degrees. What was your y value? A half. So that's why we've got the 0 there. At 60 degrees, it was root 3 on 2. Now you can pop it in your calculator, but root 3 on 2 is 0.8666. It's pretty close to just under 9. And at 90 degrees, it's 1. So you can see how this graph is coming. Now around here, 90 plus 30 is 120. It's again just under the 9, and it plots it. Capiche? What I need you to do now is I want you to plot the cosine. So at 0 degrees, what's cosine? At 30 degrees, what's cosine? Root 3 on 2, which is just under 9. So we're going to put that there. At 60 degrees, Dan the man, are you listening? Well, I'm sort of looking and showing, and you've got your eyes on your laptop. It tells me that you're interested in basketball too. And I'll remind you, if I think you're using your laptop incorrectly, I will take it. Shut it. I will come and see all your tabs in a minute. So 60 is a half. What's 90? And so on. What's 120? Oh, now it's minus a half. So can you do that? Connect the dots. Be connected by a smooth hand, right? And what we have is, this is now the cosine graph. Couple of things to notice, and I hope you notice a couple of things. One, hey Tom, what do we notice about the sine graph and the cosine graph? What are the similarities? It's a shift, it's a translation, right? You've just moved one, oh, didn't want that. You've just moved one over to the other, yes? I also would like to think that you can see that, let's take a half. When we're looking at the sine graph, you haven't just got one value for a half, but you've got 2. So there's 2 values. This graph is never ending. It keeps on going. So this is going to keep on going and going when one way, and the other just keeps on and on and on. Same with the cosine graph, right? That's what we showed you on the doodad. We good? Right. Now, as I said, there's lots of stuff that goes on in your textbook here. So this irritates me something shocking. SATC. And students will tell me, SATC. Now, this is very useful to us later on, but like, what is it? Anyone want to have an idea before they read? They are quadrants, and we should know from earlier maths that we've got the first, second, third, and fourth quadrant. That's okay. But what is this whole SATC? When we have sine, cosine, tangent. Ooh, no. So that's all. That's sine, tan, and cosine. And what they're saying is these are the quadrants. This is important. These are the quadrants that they're positive in. So in this quadrant, sine, any value for sine, cosine, and tangent are going to be positive. In this quadrant, only sine is positive. In the third quadrant, only tan is positive, and in the fourth quadrant, only cosine is positive. Now, students do the whole, remember, SATC. Oh, that hurts me. It hurts me. Because if we're talking about our circle, our unit circle, and you know that's actually your cos axis. This is actually your sine axis. Do you remember tan theta? Oh dear, that's looking a bit wobbly. What is tan theta? Tan is sine theta over. So think about your whole x and y stuff. Isn't your x positive here? Your y is positive here. Yes? So sine is positive because it's going up. Cos is positive because it's in the positive section there. And tan, positive over positive, that means yes, they're all positive. Agreed? What about in this quadrant? We're going to the left. That's cos. So what happens to your cos values on the left? They're negative. But your sine is positive. So what's tan's issue? It's got to be negative because tan will be sine over cos, positive over a negative. Different signs, negative answer, yeah? So that's why here only sine will be positive, the value thereof. And look at your unit circle, right? All of your sine values in this quadrant, they're all positive. Do you agree? Yeah. So that's all we're saying. They're just, what's the value, positive or negative? Okay, downstairs. Cosine is negative. Sine is also negative because you're going down. So tan, negative on a negative makes a. So tan is the only one that's positive. And then, of course, here, cosine's positive, sine is negative. Different signs, that means tan will be negative. So cos is the only one that's positive there. So whenever you now see this SATC, and I say, yeah, but explain it, you should be able to, because you're thinking of your x and your y axes, which you learned in year 8. Which quadrants things were positives and negatives in. Agreed? Or have I scared you? Happy days? That was a thumbs up, by the way. I mean, all silly turtles crawl. Oh, no. It's on your x and your y axis, and which is positive, and knowing that x represents your cosine, okay? Sometimes these things are cute. In this case, it's just no. No, no, no. All right. How can I get tan from here? Just from that, what was that angle? That was 330. Without using your calculator, you should be able to tell me what tan is. Why? Because what is tan? Tan is sine theta over cos theta. And remember, what this is saying is that this is, what is this? That's not sine. That's cos of 330. This is sine of 330. So therefore, tan of 330 is minus a half divided by root 3 on 2. Agreed? When you're dividing fractions, what do you do? flip and reverse the sign. Those with the graphics, pop that in. What is tan of 330 degrees? This is a manners thing in maths. I'm sorry. I'll stop talking soon. This is a manners thing in maths. 1 on root 3, it's a bit like, my friends, it's a bit like Vavanopoly, right? If you have a square root on the bottom. You know that one? That was Joey. So we say that's rude, that's poor form. How do we get rid of that root 3? Well, we times it by root 3. Because what is root 3 times root 3? 3. But you know the old fraction rule, what you do downstairs, you got to do upstairs. So that's why 1 on root 3 is the same as root 3 on 3, because that is technically just 1. You're timesing it by 1. So your calculator will always write that, but it's the same thing. I've talked a lot, and people are just sort of tuning me out. So we've sort of got this. I don't need you to do that. Don't need. Ooh. I mean, I don't think we need this either. Okay? We've just talked about that, about what's positive and what's negative from the quadrants. Okay? Is this scaring us? Why should this not scare us? Sorry for those at home, this bit here. Why? Maybe Tom for a little bit. But what does pi represent? 180. So what's 180 divided by 2? 90. Is that okay? Right. Quadrant 2. That's this one. So it's going from pi on 2 to what's here? What's 180 degrees, which is how many radians? Oh, I've lost you. Pi! I've got you back. So I'm not that concerned at the moment with the whole pi stuff. It comes naturally. All right. What I'm going to ask you to do is, I'm just going to come and chat now. 131, we're going to look at question 7. And what you're going to do is discover some stuff without me going blah, 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 and you can talk a little bit. All right? And I might give you 1 minute to look at the score. Oh, you're a goner. He just did. He said he just did. That's not good. That's not good. Okay, so page 1. What exercise is this? 5C. Oops. So we're going exercise 5C. That was Promethean Man, I think. I've asked about 7C. Justify your answer. And I'll be honest with you too, I would find that difficult to justify and explain without using my hands and writing whatever. So if we have a look here, this is your theta, and in our case, our theta was 30 degrees, and this is your sine. Do we agree? And what they're saying is, why is it the same as this one? And remember, we're saying sine 180 minus theta equals sine of theta. So if you're noticing, that angle and that angle, that answer is the same because we're taking sine of this, which is 30 degrees, so sine of 30, and this is now, if that was 30 degrees, what's this angle here? 180. So yes, this is 180, take that angle, 180 take theta, which is why this equals the same as this. They're balanced. Now, how do you sort of say that nicely in a sentence? You could read the back of the book and the answers if you so desire, but I'm more than happy that you can observe. Now, as we're here, a lot of you are going, will it be the same for cosine? And you can see straight away that it is not going to be the same for cosine. But it's pretty close. What's the difference between this answer and this one? So could you come up with a prediction before you even do that question? What do you think? It's going to be cos of 180 take theta equals negative cos of that answer. Have you done that question? No? Oh. But you're just looking. So we're predicting. We're thinking, is this going to be the rule? We're not quite sure. We don't care if it's wrong. We're now going to go and have a look. Yeah? So, eek. Oh my God, is it nearly lesson over? Eek. Okay, I need to get you doing the next little bit. So can you please pay attention here? Because I think you can finish this reasonably quickly. I do not need you. Do I need you to copy the table? Yes, okay. All right. Well, your homework will be finish that exercise maybe and write your rules down. I really want to do this. Well, do you know what? We're going to do it right now in 1 minute. No, just to show you. Some of you will carry on, some of you won't. Okay, the bell beat me. I will stop.